Hello everyone. In this video, we are going to discuss FLSM, fixed length subnet masking. Today we will divide a network into smaller subnetworks of equal size. The question statement here is to divide a network into 5 smaller subnetworks of equal size for class C IP address. Here we have taken this IP address 196.168.10.0. We know that a subnet mask is a sequence of ones followed by zero, where ones represent the network ID, bits of network ID, and zeros represent the host bits. By default, for any class C IP address, the subnet mask is 255.255.255.0 because the first three octets they consist of the network ID. That is why we allot 1 to them. And the last octet is for the host bit. That is why we allocate 0 to them. Now we have to divide our network into 5 smaller subnetworks. So we would take the last host bits here. These 8 dashed lines here represent the host bit. Now we have to divide them into 5 smaller subnetworks. So we will find the power of 2, that is just greater than 5. 2 raised to the power 0 is 1, which is very less than 5. 2 raised to the power 1 is 2, which is also less than 5. 2 raised to the power 2 is 4, which is also less than 5. But 2 raised to the power 3 is 8, which is just greater than 5. So here, these now the first 3 bits of the host ID would also become a part of the network ID. Now the new subnet mask for connections in this IP address would be 255.255.255. For the last octet, what we will do, we will find 2 raised to the power 7, that is 128, plus 64 plus 32, which makes it 224. So now this is the new subnet mask for all the connections in this question. Now I would distribute the IP addresses. To find the number of hosts in now a smaller subnetwork, we will subtract it from 255. So 255 minus 224, this would be 256. 256 minus 224 would give us 32. Now our smaller networks, subnetworks can at most have 30 hosts because first and last bit are reserved. Now our new divisions would be for my first network, I would start from 0 and it add 31 here for the last address. This would be the range of the first subnetwork. For the next subnetwork, I would start from 32 and then we will add 31 in this 32. We would get 63. In the third subnetwork, we will start from 64 and then we will add 31. We would get 95. This would be the range of third subnetwork. For the fourth subnetwork, we would start from 96. Now I would add 31. I would get 127. For the fourth network, we would start from 128. Then I would again add 31. I would get 159. Here, I can have 8 subnetworks, but we only need 5 as it is mentioned in the question. Now let us implement this in Cisco Packet Tracer. Since 1841 router has only 2 ports, so now in router 1, I have to add an additional port so that we could connect it with router 2. The connections are now done. Now I would assign them IP addresses. This would make my first network, and this one would make the second network. This would be the third network, and this would go for the fourth, and this one would go for the fifth network. And these are the ranges of the IP addresses for the networks. This would be the range for the first one. This is for second. This one is going to be for the third one, and this would be the range for fourth, and this would be the range for the fifth network. Don't forget to change the subnet mask here. Our first network is done, and now I am configuring the second network. This is my fourth network, and for the fourth network, our range starts from 96. So I would here give it 97, and the next router would get 98. And for the fifth connection, our ranges start from 128. So I would give the first router 129 and the next one 130. Now the IP addresses have been assigned. Now comes the tough part where we have to do the routing. I would start with static routing. So this router, it knows about this network and this network. I have to give him information about this network, and this network. Starting with this network, network 2. For router 0, router 1 is always going to be the next hop. So here in next hop, I would provide the address of router 1, which is 98. I here made an error in the subnet mask, which is 224 and not 242. This is the second network I would tell it about. And finally about this network. For first router we are done. Now for the second router, for router 1, for this address, router 0 is going to be the next hop. And for this network, router 2 is the next hop. Now we have made all the connections, assigned the IP addresses, and did static routing. Let us send the messages and see if it is working or not. Don't forget, first few messages are going to fail. See, the third message now has been successfully sent. And now any message from this computer to this computer would be sent successfully. If I try to send from this computer to this computer, the first message could fail. Here, it failed. But the second message was successfully sent. So this was all about fixed length subnet masking FLSM. You can also use dynamic routing, but don't forget, for dynamic routing, you cannot do that with GUI. You have to use the CLI in CLI commands to give different addresses. One last thing that I would like to discuss is, suppose if we had to divide it into, we had just the same question, but we had to divide the IP address into three smaller subnetworks. So for that, here we reserve the first three bits because 2 raised to the power 3, that is 8, was the number that was just greater than 5. Now for three smaller subnetworks, 2 raised to the power 2, that is 4, is just greater than 3. So we reserve the first two bits as a part of the network ID. So now our subnet mask would be, instead of 255.255.255.0, it would be 128 plus 64. That is, we are going to divide a network into three smaller subnetworks of equal size for a class C IP address. The by default subnet mask should be 255.255.255.0. But now we have to divide into three smaller subnetworks. So a number that is just greater than 3 and is the power of 2 is 4. That is 2 raised to the power 2. So in the host bits, we will reserve the first two bits and the rest 6 bits would be a part of host ID. Now the new subnet mask, for new subnet mask, the last octet would be 128 plus 64. That is 192. So for our new connections, the new subnet mask would be 255.255.255.192. And every connection could have 256 minus 192, that is 64 hosts. And the new division of IP address, if I want to show you that also, it would be 196.168.10.0, and then I would add 63 in it. which would make it 63. The next subnetwork would start from 64, and then I would add 63 in it again. And then last network would start from 128, which would make it 191. So, and similarly, then you would draw the arrangement, make connections, put IP addresses accordingly, and you can send your message. That's all I had to discuss for FLSM. Thank you.